Coming up on this special edition of the Black Vault Radio, the senior astronomer from the Search for Extraterrestrial Intelligence, or SETI Institute, Dr. Seth Shostak, steps into the vault. We talk about the hunt for radio signals in the cosmos, the vastness of the universe, alien life forms, and yes, even UFOs.
Every now and again, you get a signal that passes all the tests, and the software says, I don't know what it is, and it throws up its little software hands and says, you take over. I don't know what this is. You know, we like to think Earth is the best place in the universe for life, but maybe that's wrong. I ask people to send me videos and photos if they've made them, and I look at those, and, I've never found one where I thought, my God, that's something that couldn't be just, internal reflection in the lens of the camera and that sort of thing. The fact that there are secrets shouldn't surprise anybody. Of course there are secrets. The question is, are they covering up evidence of aliens?
All that and much more. So stay tuned. The Black Vault Radio is about to begin. More than 20 years ago, I began a journey. My quest for the truth. My name is John Greenewald, and I have hammered the United States government with Freedom of Information Act requests trying to get answers. I have more than 2 million pages of declassified documents for you to download at theblackvault.com. Now, I attempt to dive even deeper and talk to some of the most brilliant minds on this planet. No government secret is off limits, and no question is off the table. All I aim for is the truth. This is the Black Vault Radio. That's right, everybody. This is the Black Vault Radio. I am your host, John Greenewald Jr. As always, thank you so much for making this your podcast and radio show of choice. There are a ton of options out there. I know it. I see them all the time. So thank you so much for making the next hour and a half or so your choice to listen to. I'm super excited about this special edition of the Black Vault Radio. As you know, with special editions, I have various audio segments and update you on not only some new documents, sometimes news, but also dive into the TBV Unredacted segment. In a special edition, we drop those where I just bring on the guest. It's all about him. Dr. Seth Shostak is coming up in just a couple of minutes. I want to take this opportunity to ask you all, I hope you have subscribed. If you have not, the Black Vault Radio tries to bring a show a week at least with some of the brightest minds on this planet, as I mentioned in the very beginning. And Dr. Shostak is definitely one of those individuals, and it's an honor to have him join us, talk a little bit about SETI, and talk about what they do, what they're searching for, who they're searching for, and we even will dive into the UFO phenomenon a bit, as he has been gracious enough to field some of those questions so we can see what he thinks and just see what his reservations are on the UFO evidence or the lack thereof that's actually out there. So if you haven't subscribed, I hope you do so. You can do so on our YouTube channel at www.theblackvault.com/originals. That is a brand new channel I had to start. So if you think that you've subscribed to the Black Vault in the past, you may have. But if it was not in the last 2 weeks or so, here in the beginning part of December of 2018, depending upon when you're listening, just go to theblackvault.com/originals. That will forward you to the YouTube channel where we're going to be having a bunch of new content, not only this radio show, but much, much more. So definitely subscribe to that. And of course, most popularly iTunes. This is available on iTunes and pretty much every other podcast aggregator that's out there. If you have your own and you want the RSS feed, just go to www.theblackvault.com/show notes. That's also where I'm going to be linking to what Dr. Shostak and I talk about, SETI Institute homepage. This is episode number 18, so just go to theblackvault.com/show notes. find episode 18. That will link to everything that Dr. Shostak and I talk about, including the links to subscribe to this show. Thank you so much again for tuning in and listening. Dr. Seth Shostak of the SETI Institute is coming right up. Stay tuned. In this episode's TBV Dialogues segment, I welcome the senior astronomer at the Search for Extraterrestrial Intelligence, or SETI Institute, Dr. Seth Shostak. For much of his career, Dr. Shostak has conducted radio astronomy research on galaxies and has published approximately 60 papers in various professional journals. He's written more than 500 popular magazine, newspaper, and web articles on various topics in astronomy, technology, film, and television. He lectures on astronomy and gives approximately 60 presentations annually. Each week, he hosts the SETI Institute's one-hour science radio show, Big Picture Science. Dr. Shostak has also written, edited, and contributed to a half-dozen books. His most recent is Confessions of an Alien Hunter, a scientist's search for extraterrestrial intelligence. Dr. Shostak, welcome to the Black Vault Radio.
Thank you very much, John.
It's an honor to have you on. I have actually mentioned you before. I have a lot of respect for the SETI Institute and you specifically. For the audience who didn't hear those past shows, the short of it is Dr. Shostak was a guest on a couple shows that I produced for History Channel and for Discovery Channel. He's an excellent guest. He knows his stuff. His resume speaks for itself. So I want to pass it to you. I want you to give the audience a little bit of a background on what exactly is the SETI Institute.
Well, actually, it's a nonprofit research organization, and we're interested in research that bears on the question of life beyond Earth. It got started, 1984, so that's quite some time ago, strictly as a sort of it was a bureaucratic mechanism, actually, to deal with the then existing NASA SETI program, which was to do what Jodie Foster does in the movie Contact, use a bunch of radio antennas and try and eavesdrop on ET. That was the only project. And it was funded by NASA. It was a NASA project. But if you had a nonprofit organization sort of channeling the money, you kept more of the money for the research and less of it went to overhead expenses like offices and computers and phones and copy machines and all that. So that's how it got started. Today, if you walk down the halls of this institute, you'll find that about 95% of the scientists are not doing SETI. They're interested in what's called astrobiology. They're interested in life in space, but life that might be a lot closer than ET. Microbes under the surface of Mars or under the icy skin of some of the moons of Jupiter and Saturn.
That's what I was most amazed by when I did get to walk through those halls. When we interviewed you there, I drove up with the crew. We got to walk the halls. I was really, really surprised and also amazed at the amount of research that you all do there. Because again, you do have that kind of aura that it's just you're sitting at computers, looking at, screens, waiting for some radio signal to arrive. But talk to me briefly about some of the other research angles that SETI does away from the radio astronomy. Like, what exactly are you guys doing?
Well, if you ask, where are we most likely to find life in space? And we haven't found it so far. I think most people will know that. There have been claims, of course, but we haven't actually proven it to the degree of satisfaction that a scientist would want. You might say, well, okay, using these big antennas to try and eavesdrop on ET, that might be something that pays off tonight. You might hear a signal. But on the other hand, we now know that there's, that Mars might be a good place for life. I mean, people have been speculating about Martians for a very long time. There might actually be some Martians. There might have been some Martians a couple of billion years ago where there was liquid water. So I think the single most studied object in the halls here of the SETI Institute is probably Mars, our little ruddy buddy. And, they're using data from various NASA rovers, landers, orbiters to try and figure out, all right, we want to go look for life again, but where on Mars should we look, right? Don't just plop down at a random place. Maybe there are better places. But there are also people who are interested in the moons of Jupiter, the 3 moons of Jupiter that might have liquid oceans. There are at least two moons of Saturn that might have liquids, water or liquid natural gas. I mean, these are all places where there could be life. Now, this would be life you'd need a microscope to see. It's not going to stand there and talk to you. But if you could find that sort of thing, at least you'd know there was biology out there. There are more than a half dozen places just in our solar system, and that's mostly what they're studying.
Is there a consensus on where the SETI Institute scientists and the research staff there believe we will find actual life first?
No, I think that's the subject of a lot of cocktail party speculation.
Mm-hmm.
I bet everybody in an audience in Germany about 8 years ago, I don't actually recall exactly how long, but I bet them all a cup of coffee, that we would find ET, a signal from ET within 24 years. Yeah, I still stand by that, although I'm not sure I can afford all the coffee now. But the NASA scientists think they're going to find life within 20 years. They've said that recently, so maybe they heard my bet and decided to get in with a bet of their own.
So just to someone like me, and I don't understand a lot of this, but you obviously have an extensive background, why a radio signal over, I don't know what else, but over anything else? I mean, why was that kind of the focal point of the original SETI's vision of finding a message from another planet or another world?
Well, some of that is simply historical. We invented radio, well, let's say around 1900, practical radio, although the theory for radio was understood at the time of the American Civil War. So that's quite an old idea anyhow. And the technology dates from the 20th century, and the ability to use radio waves that could actually get through the ionosphere of the Earth, could go through all the gas and dust between the stars. That all dates from the invention of radar fundamentally. So say the Second World War. Okay, so since that time, we've recognized that radio is an easy way to send bits of information from here to there. Now, if you ask, well, are there any other ways? Well, sure. I mean, you could, just package up a bunch of thumb drives and put them in a rocket and send them somewhere. That's one way to send information around, but it's pretty slow, and you need to know where you're going. You could use lasers, but lasers and radio waves are basically the same thing. It's just that the laser was invented a lot later than radio transmitters were. But we do, to look for flashing lights too. I get phone calls all the time from people who say, oh, well, radio, that's pretty old school. Why don't you use gravitational waves or neutrinos or, this whole laundry list of other things you could think of. But all of them have disadvantages that, suggest that, well, no matter what else ET might be doing, they're always going to use radio in the same way that, we always use the wheel, even though it's a pretty old invention.
Mm-hmm. Now, has there been any discoveries? I know just kind of from legend and lore, there's the wow signal, and I want you to explain that. But in the years that SETI has been around searching for these messages, have you found anything where it really made you go, wow? Pardon the pun.
Oh, yeah. Well, we didn't find the wow signal. That was a detection made at the Ohio State Radio Observatory. Bless its heart. It's now been turned into something else, a housing development or a golf course or something. But we pick up signals all the time. I think that the public doesn't appreciate the fact that, you don't just sit around with earphones on waiting for a signal. They do that in the movies because it's somewhat more dramatic. But the reality is the listening is really done by computers. And because you're listening to so much of the radio spectrum at any given time, so much of the radio dial, you pick up signals every couple of seconds. There's another signal. But these are all due to, or have been all due to, telecommunications satellites mostly. So you have to filter all that out. It's a rather uninteresting thing to do, but you have to do that. And fortunately, the software can do that for you, or even using artificial intelligence to help us do that better. But every now and again, you get a signal that passes all the tests, and the software says, I don't know what it is. And it throws up its little software hands and says, you take over. I don't know what this is. That doesn't happen very often. That happens every so many years. So we have had a couple of signals where we thought this could be it. Most famously one in 1997 where, we really got excited, but it turned out not to be it. But at least it showed what happens if you really pick up a signal.
So what do they ultimately turn out to be?
Well, most of them, they're all what you call terrestrial interference, which is just a big catch-all for anything that isn't ET, really. The majority of them are satellites. You know, there are thousands of satellites orbiting the Earth, and, you know, they're doing all sorts of stuff. I mean, they're obviously sending back the weather, they're providing the imagery you might get on Google Earth, and of course, there's a lot of defense-related stuff, spy satellites and whatever, and telecommunications satellites, right? If you're watching a television broadcast from Europe, or for that matter, even getting a phone call from Europe, right, that goes via satellite. So, and your GPS, it's also satellite. So all these things, almost all of them have transmitters on board, because otherwise it's not very interesting. Whatever they're doing, you know, stays where they are. It's, you know, you don't want it to be Las Vegas. You want to get that information back. So they all have transmitters, and they're all up in the sky, these transmitters. So, of course, you pick those up all the time.
Talk to me a little bit about how you figure out where to point the radio telescopes to search. I mean, obviously, you're doing a lot of research on where you're pointing these things to, but talk to me about how in-depth you have to go to figure out if intelligent life is out there. Where are you going to point these telescopes to?
Well, that's something that interests me in particular. And in fact, it's a little tricky because, you know, you can be very conservative. And in the past, we've sort of taken this conservative approach where you say, well, look, what kind of star system should we point the antennas at? What kind of star system might have a planet sort of like the Earth where the aliens are hanging out? And, you know, our star, it's called a G-type star, but a sun-type star, maybe 8 or 10% of all stars are like the sun in terms of their size and brightness. So in the past, that's what we did. We just point the antennas in the direction of those stars. We didn't know if they had planets, but we, you know, had to sort of make the assumption, well, I mean, maybe they do. Well, it turns out now we know a lot about planets around other stars. And this is one of the hot topics in astronomy of the last 20 years. And it turns out most stars have planets. It's amazing. You know, almost all of them have planets. They're very, very common. It's like saying, you know, well, what fraction of the houses down the street have a plant in them somewhere, you know, house plants. And they're very common. Okay, so they're the same with these planets. But we've actually switched gears a little bit and said, well, maybe stars like the sun are maybe not the best places. You know, we like to think Earth is the best place in the universe for life, but maybe that's wrong. So we've been looking recently at a lot of what are called red dwarf star systems. And those are just stars that are smaller than the sun, but there are lots and lots of them. And there's some advantages to these little diminutive stars if it turns out that they can host planets with life. They have planets, but we don't know if they have any life on them.
So why red dwarf stars are you looking at? Like, what was the turning point on going away from the proven formula here in our solar system? What was the shift?
Well, I think that the shift was largely the discovery that a lot of these red dwarfs seem to have planetary systems, planets that might in fact have, you know, liquid oceans and maybe atmospheres and maybe something on them. Okay. In particular, they're the nearest star to us, the nearest other star to our solar system. It's, you know, called Proxima Centauri. So you can't really see it from the northern hemisphere. You can see it from the southern hemisphere. It's a star about a little over 4 light years away. Okay, that's pretty close when it comes to distances to stars. It would be a long drive, but you know, it's relatively close. And you know, it was discovered to have at least one planet a couple of years ago, and that planet, you know, looks like it is the right distance from its star. It might, you know, have temperatures that are suitable for life, if you will, not above the boiling point of water, not below the freezing point, and all that sort of thing. And Proxima Centauri is a red dwarf star. So clearly here was an example. The nearest other star system was a red dwarf with a planet around it that might be habitable. Okay, so they don't look like bad places to look. There's also a system called TRAPPIST-1. It was found by a team led by some astronomers in Belgium, actually, which accounts for the name. And there were 7 planets around it, and they were all more or less the same size as the Earth, and at least 3 of them are at the right distance from the star so that they could be possibly inhabited or habitable. So it looked like, hey, you know, these red dwarfs, I mean, they've got planets, and they're also on average closer and very much older than the sun. And being older might actually be a good thing if you're looking for ET, because, you know, those planets have had more time to cook up something clever.
It's absolutely amazing to hear you talk about this. I want you to give the audience an idea, just an overview anyway, of how big the universe really is, and if you could come down to how many exoplanets that we have found thus far, or approximately, I don't know if you have the exact number, but I think the audiences and general public doesn't quite understand the amazing magnitude of this type of research that's going on right now. I mean, the news is filled with politics and, terrorism and attacks and war and blood. And we just don't hear about the great science anymore. So give the audience an idea of what really is out there here with 21st century terminology and science, and how big is it?
Well, it is big, as I guess it was Douglas Adams said. The universe is big, really big. I don't know. It is. That might have been William Shatner. Anyhow,
whichever.
Whichever. Yes, but it is big, and of course, everybody will admit to knowing that. But to really appreciate it, you almost have to do what they do in fourth grade, and that is build some sort of model. And so, imagine in your head that we take the sun, we shrink it down to a ping pong ball. Not easy to do, but exercise left to the student. So you shrink it down to a ping pong ball, and then the Earth is a little tiny dot. You barely can see it. That's a couple of feet away, and Jupiter's 5 times that distance, and Pluto is outside in the backyard somewhere. But the nearest other star on that scale, which is the nearest place you could hope to find intelligent life, because it's probably not anywhere in our solar system except for Earth, there's another ping pong ball, but on that scale, it's, the distance from New York to Salt Lake City, something roughly.
Wow.
Okay. So the nearest star, even the nearest star, that's a big distance. And of course, on television, that's never a problem. You just call up Scotty in the engine room and say, warp 6, Mr. Scott, and you can get there. But in reality, it's very, very difficult. It's not like going to the moon or Mars. It's a completely different order of magnitude problem. Okay, but that's the nearest other star. Now you have to imagine, these ping pong balls extending all the way to the moon and beyond, that kind of distance. And now you get our galaxy, right? That's just a couple of 100 billion stars, a kind of a neighborhood of stars. And that means there, in that neighborhood of stars are like 1 trillion planets. Okay, I mean, everybody's eyeballs are glazing over like Krispy Kremes by this point because these numbers are big, but our galaxy is one of about 2 billion galaxies we can see. And that's the visible universe. That's a part of the universe we can see. There hasn't been enough time since the Big Bang for light from things that are farther away to get to us yet. But that could be a tiny fraction, and perhaps an infinitesimally small fraction of what's really out there. Okay, so it's big, it's brawny, it's beyond the kinds of imaginings we're easily capable of. That's a fact. But of course, we're wired up to survive on the savannah and not think about topics like cosmology.
It's just an astounding number to think about. Now, out of that number, are you, Dr. Shostak, personally convinced that intelligent life is out there somewhere?
Yeah, well, I am, obviously, because I'm still in this job, right? I mean, yeah. I'd be repairing automatic transmissions or something a little more lucrative if I didn't think that there was something out there. But it really comes down to this. I mean, it's not that you can argue, till the cows come home about, well, I mean, how many planets are sort of like Earth and what's the chance that life will develop on them and so forth. There are endless arguments about this and discussions and research papers for that matter. But in the end, it's just a numbers game. If there are 1 trillion planets in the Milky Way, which is roughly the number, and there are 2 trillion other galaxies, each with 1 trillion planets, well, that's a lot of planet pleasure. I mean, that's an incredibly large number. And if Earth is the only place where there's intelligence, then there's some sort of miracle going on here. And, a lot of people think there are miracles going on here, such as their own birth, for example. But, in science, usually to say it's a miracle, Bob, doesn't get you very far.
Now, I know there's been attempts at calculation. You referenced a lot of papers that have been written about this and a lot of pontificating, trying to figure out exactly how much is out there. I know that Frank Drake had created the Drake equation to attempt to calculate this. Can you explain that and then let us know, is this still kind of the standard to figuring out the number of intelligent civilizations that are out there?
Well, the Drake equation indeed was cooked up by Frank Drake who's one of the people that was involved in the founding of the SETI Institute. And Frank, he's kind of retired now. He's in his late 80s, but he still comes in every couple of weeks. Frank will come in for the day and so forth. And that's always a wonderful thing from at least my point of view. I think from everybody's point of view, because Frank is, of course, very sharp, very interesting, and the world's last nice guy. He is an incredibly nice guy. So I enjoy, he's one of my heroes. But anyhow, Frank did the first modern SETI experiment back in 1960 using an antenna in West Virginia, pointed at a couple of nearby stars, and spent some time trying to eavesdrop. That was the first time it was done in a serious way, and it generated a lot of interest. There were big magazine articles. This guy's listening for the aliens, that kind of thing. And as a result, the National Academy of Sciences, I think that was the organization, asked Frank to have a conference about this subject because it clearly generated so much interest the following year. So in 1961, there was a small meeting, about a dozen people, and Frank Drake needed an agenda for that meeting, and he came up with this equation. Now, the equation, was really intended as a discussion point. It's not like E equals MC squared, where you can actually do some physics with that. It was simply to say, okay, if you're going to look for ET, what are the chances you're ever going to find anything? And so it just tries to estimate, well, how many societies are out there in our galaxy, in the Milky Way galaxy, that are broadcasting radio signals right now that we could pick up? They're just zooming through through our bodies and our cities and our planet. How many of them are there? I mean, is it one, or is it a zillion, or what is it? And so it depends on how many planets are out there and what fraction of them cook up life and what fraction of those cook up intelligent life and how many of those guys are still on the air and all these things. So there's 7 terms in the Drake equation. It's just a discussion piece. It's still used today. I mean, we still talk about it a lot. It doesn't give you an answer because you don't know many of the terms, but open up any Astronomy 101 textbook and you will find the Drake equation in it.
Yeah, and that's why I wanted to bring it up, because it is fairly prevalent of calculating intelligent civilizations. And as you said, there are variables that we just don't know the answer to. There have been many scientists that have tried to plug in those variables and come up with a number. Does SETI, as an institute, do they have a solution to that equation, or do you really stand firm that it's only for discussion, not to be used for anything else, even hypothetical scenarios?
Well, honestly, I think that there's a lot of value in the equation. It would be great if you could come up with a number, and people do ask that. But the problem is it depends on things like, this. Suppose that there are a million planets out there in our galaxy that not only are kind of like the Earth in that they have, watery oceans and atmospheres and all that, but they actually have life, that they cooked up some microbes, right? And maybe they've got trilobites. And one of the terms in the equation is, well, what fraction of those million would actually cook up intelligent life that's clever enough to build a radio transmitter or flashing laser or something? Well, how do you know? I mean, you don't know. Obviously, it happened on Earth, but that's a sample of one. And anybody who's taken introductory statistics know that if you only have a sample of one, you're not in a very good position to estimate what the actual probabilities are, because maybe you've just been really lucky. Or maybe everybody wins. I mean, you don't know. So that's the problem with the Drake equation. You can't actually come up with any estimate that is based on observations, because you don't know so many of the terms. Now, you can certainly ask people, and people do that all the time. They ask Frank Drake, all right, what do you think is, the bottom line of your equation? And Frank typically says, I think there are 10,000 societies out there in our galaxy that are broadcasting now. But if you press him on that and say, well, where'd you get that number? He will admit that's just his opinion. It's a guess. It's a guess. And that's going to be true for all the people who venture an estimate on the Drake equation.
Now, I want to talk a little bit about your searching for radio signals, and you started, what year was SETI founded again?
Well, the Institute was founded in 1984, so that's quite a number of years ago.
Now, as science progresses on Earth, does SETI shift the way they are searching for signals? Now, I assume you've changed a little bit about where you're pointing your telescopes to. We talked a little bit about that. But the types of signals, I mean, maybe that's a silly question, but have you kind of altered the way that you are looking for signals, or has it always been the same methodology?
Well, it's a kind of I don't know, a combination of ingredients product, because obviously several things have changed since 1984, for that matter, since 1960, when Frank Drake did that first SETI experiment. Two things: the technology changes and the science changes. We've talked a little bit about how the science has changed. We know that planets are very common now. We didn't know that in 1984. I mean, we didn't know whether there were planets out there or not. Now we know that they're just they're like telephone poles. They're just lots of them. Okay,
Mm-hmm.
so that's something that's changed. Now, has that changed the strategy? Well, a little bit, because now you don't have to worry about which star systems have been discovered to have planets. You can just point at a random star system and have a 70 or 80% confidence that there's some planets there. So, that changes what you do a little bit. But so the science has changed. Also, we understand better about what makes a planet habitable. What kind of an atmosphere do you need, or, what kind of star systems might have habitable planets. These are all the results of just sort of basic astronomy research. So that's changed a little bit. I don't know that it's changed the strategy terribly much, but that has changed. The thing that's changed the most, of course, is the technology.
Mm-hmm.
And so today, the experiments that you're doing, are literally estimated to be like maybe 10 trillion times faster than what Frank Drake was doing back in 1960.
Yeah.
But that's mostly the development of computers. So, yeah, I mean, it's really like, somebody sends you into the South Pacific and says, okay, there are a bunch of islands out there, and some of them might have a buried treasure in a chest under the sand. So we're giving you this teaspoon, and go out there and try and find some of that stuff, right? But over the course of time, the teaspoon gets replaced with something bigger, a tablespoon, and then eventually a shovel, and then some sort of mechanical trenching device, or who knows what. So that's what happens with SETI, that this experiment speeds up, and if there's something to find, you'll find it more quickly.
So the science behind all of this is fascinating, but more so to me, it's what happens next. So let's say you and I, we do this interview, we get off the air, and all of a sudden your computer raises its hand and says, I don't know what to do with this. You guys see a signal, and it really does turn out to be a message from another world. What happens next?
Yeah, well, that's a question that I think interests a lot of people, and it interests me, to be honest. I've tried to write a bunch of papers on about what happens, because the public seems to be somewhat misinformed, or if not misinformed, at least of the opinion that what would really happen is that this signal would all be covered up, that the government would move in here on our nonprofit and just shut it all down and say, look, you guys, we're going to keep this under wraps. And I find that a very large fraction of the public thinks that's what would happen. I usually ask, well, why? Why would they do that? This would be a big story. Everybody here would be, in line for a raise, or I don't know, at least a good dinner, if we were to find a signal. So why would you keep that quiet? You'd want everybody in the world who has a telescope to study this thing. And they said, well, because the public couldn't handle the news, which I think is a little silly. We've never noticed that. When we had our false alarm, it wasn't that the public couldn't handle the news. It wasn't that the men in black showed up. It wasn't that the president started calling. The newspapers started calling. They not only could handle the news, they wanted to print the news. So that's what would really happen. We know that on the basis of these false alarms, that what happens is, if you get a signal that looks interesting, to begin with, you don't keep it quiet. There's never been a policy of secrecy here. The boss has never said, all right, if you pick up a signal, don't tell anybody. Everybody will start sending emails or start writing on their personal blogs or whatever. But what happens is that the media come in immediately within hours, and they're calling you up and they want to know what's going on. So that's what happens. In the short term, what happens is it's a huge story. It's just a big story. Okay. And people will want to know more. And of course, you would do more observations. It would be, everybody would be in the game, and suddenly there might be even real money in the game. And so you could build even better equipment, and maybe you might learn something.
What about taking the next step, jumping ahead a little bit? So it's a big media story. Obviously, everybody's getting the raise and patting themselves on the back saying, I told you so. We were doing this research for a reason. What happens then with the communication itself? So let's say you receive the message. Is there a set of protocols or procedures or anything when it comes to communication, and ultimately who does the communication?
Well, there is a set of protocols. It's very simple. The set consists of three things. I was involved in the redrafting of the protocols because the original ones were a little inconsistent. We sort of improved them a little bit. But all they say is if you find a signal, check it out. Well, okay. 2, tell everybody. All right. A lot of people won't believe us when we say that, but it happens to be true. And 3, don't broadcast anything back without, talking to all the other nations of the world and see if they're down with that idea. Okay, that's all it says. I think that there's a misconception here that's important, and that is that if we pick up a signal, there will be a message in it that we could do something with. In other words, there'll be bits. There'll be a modulation of the signal. Right? If you pick up a TV signal, it isn't just a constant whine on TV set. I mean, it has, it's changing in frequency and intensity millions of times per second, because that's the picture and the sound information. But if you're looking for ET, your receivers can't follow any of that because you're trying to find very, very weak signals. So you trade off that sensitivity for the ability to pick up the message. So in general, if we were to pick up a signal, we wouldn't have the bits of information. We couldn't just put them on the internet and say, all right, everybody, see if you can figure any of this out. I mean, that would be great. And eventually, I suppose we could do that, but you'd need a completely different instrument to pick up the message. I think that that's not appreciated by the public.
Yeah, well, I think that that's definitely a misconception, and even myself, and I look into this stuff a lot, wherein it always is in movies and television shows that when you receive a signal, SETI's going to get a picture or a diagram, or Carl Sagan obviously popularized the schematics to building a machine. That's not necessarily what you're looking for. You're just looking for evidence that something is out there broadcasting a radio type signal that you're going to detect. Is that right?
That is right. Yeah, indeed. I mean, in the old days, in the NASA days, people would say, well, we're looking for the on the air sign to be illuminated, but we don't know whether the programming is, top 40 or 24-hour news or talk radio, or whatever it is. You don't know anything like that. All you know is that there's somebody up there with a transmitter and it's on. That's what you know. And you could say, well, okay, I mean, is that somehow dangerous? Should the governments, keep that quiet? Well, I don't think so. But, it's hard to convince people that the government wouldn't step in and shut all that down. But it is important to recognize that you're not going to get the bits. I mean, there's some exceptions where if they sent the information very, very slowly, sort of like Morse code from somebody who's half asleep, you might be able to pick some of that up. But it's unlikely that they would do that. I mean, that doesn't make any sense to me. If you're an advanced society, you don't spend a lot of money to send, a couple of bits per second.
But in fairness, didn't we as humans do that and have a couple times?
We've not done very much broadcasting, actually. Here at the SETI Institute, we don't broadcast anything. We don't even have transmitters. But there have been groups, and there still are groups, who would like to broadcast stuff. And, that's been done on occasion, mostly as stunts. In fact, there's been no serious transmitting project because there's no money for it, fundamentally. It's not that you couldn't do it. You could do it, but where are you going to send the message? You don't know. And I think a really important point is that, the nearest society, the nearest other planet with intelligent beings with radio receivers and transmitters, they might be 200 light years away. They might be 2,000 light years away. You have no idea. But even if it's only 200 light years away, right, you send them a message. It takes 200 years to get there and another 200 years for there's a response, if there is any response, to get back to you. Well, that's a long time. Nobody's interested in winning the Nobel Prize in 400 years. So in general, that's not done. There are also people who think it's dangerous. I don't happen to be among them, but there are people who think that. So, in fact, we don't do much deliberate transmitting. Of course, humanity is transmitting all the time. I mean, your local TV station is transmitting into space, FM radio, and mostly radar. There's a lot of radar on the Earth, and all of that is going into space. So if the aliens have really big receiving antennas, they probably could pick some of that up.
There's a couple questions I want to ask based on what you just said. So first, let me start with what Earth is broadcasting, but not intentionally. Very quickly, we know that the Arecibo message, which I know was more symbolic, I think correct me if I'm wrong, where they shot the first Arecibo message to like 50,000 light years away? I mean, it was wasn't it that much? It was just what was in the sky at the time?
Yeah. Well, it's true. It happened to be a big ball of stars. It's what's called a globular cluster, a couple of 100,000 stars that happened to be in the direction where you could aim the telescope during this event, this celebration. They had just upgraded the Arecibo antenna down there in Puerto Rico, and they wanted to have a little, ceremony. So Frank Drake, in fact, cooked up this experiment to beam a message. It took him 3 minutes, and it is true that M13, which is the very attractive name of this globular cluster, is about 25,000 light years away. 25,000.
25.
So the signal was broadcast from Puerto Rico in 25,000 years, a little less now, 40 years less or something. It'll get there, and if there's anybody there and they pick it up, maybe they'll respond and say, "Hey, come visit M13. We got a lot of stars here, and plenty of used cars you may want to buy."
And we wouldn't get a response for 50,000 years because it takes 25,000 years to get there. And then if they just cooked up a message, sent it back, which obviously is symbolic. But let me go back to what you were saying about radar and some of our own TV signals. Again, not to bring it up again and beat a dead horse, but popularized in the movie Contact was one of the first strongest signals and I believe this was embellished a little bit, but one of the strongest signals was the broadcast of the Olympics in Berlin, and famously, and I'm paraphrasing, but the Earth's first ambassador to space was Adolf Hitler, as said very humorously in the movie. Is that true that television signals can travel infinitely, that they could reach a planet that's 100 or 200 light years away, or is that science fiction?
It's not science fiction. I mean, the television signals are high enough frequency, they go right through the ionosphere. They're not affected by the ionosphere. AM radio is. That's why you can pick up, some of the big Chicago stations, even though you're in California at night, because the ionosphere sort of bends these signals. So at low frequencies, it's a little tough to get your signal into space, but at high frequencies, and that means television for one, they go sailing right into space. I wouldn't worry too much about Hitler being the first ambassador because the transmitter, was so weak for that transmission that if you lived, on the sort of 2/3 of the way outside of Berlin, you wouldn't be able to pick it up, let alone at some other on some other star system. But what Carl Sagan required for the storyline was a signal that was broadcast long enough ago that there'd been enough time for it to reach these weird aliens on a planet around Vega, I think it was, and, come to Earth and interfere with Jodie Foster's gusto-grabbing lifestyle. So, those were the requirements of the story. The actual Berlin signal was very weak, and you could argue there were other signals around the same time that were comparable in strength. So I wouldn't worry too much about that. But your question about whether any signals, could be strong enough, well, all signals are strong enough. They don't ever disappear. It isn't that they go to a certain distance into space and then they say, okay, that's it. We're giving up. That's the end of this signal. I mean, the signals just keep going. They're weaker and weaker with distance, of course. It's like you take your laser pointer, if you got a laser pointer, take it out tonight and aim it at the sky. And, you could say, well, maybe somebody will pick that up. I'll just tap out in Morse code, what hath God wrought or something. And, will somebody pick that up? Well, probably not. It'll be very, very weak by the time it gets, even a mile above your head, let alone to the distances of another star. But those photons, that signal is still going out there. And if they had a big enough telescope, they could pick up your laser pointer. I mean, it'd have to be a really big telescope, but it never stops. It's just that it keeps getting weaker.
Just don't point it at any aircraft for those listening that are running out there with their laser pointers right now pointing to the sky. Is there a calculation on how far the signals that have been strong enough to go out into space, what that bubble is around Earth? I know that I'm coming out of left field with that question, but I'm just curious.
No. You can find it if you go to, very often planetarium shows will because, the planetaria have the ability to show you the sky and all the nearby stars, and they'll show you that bubble. It's essentially a bubble that has a radius, which is on the order of 70 light years, because that's the time since the Second World War when we developed radar, FM radio, and for that matter, television. So all those signals, which are the strongest to be leaving Earth, mostly the radar, they've gone out as far as, they could at the speed of light since they were first broadcast or first transmitted in the case of radar. So that's a sphere of roughly 70 light years in radius since the war. And now how many stars are in that? It's on the order of thousands. Okay. So, there are thousands of stars that, where if somebody has if there's a planet around some of those and they have a big enough antenna, they might be picking it up. But I have to say, to me, the interesting thing is it was a very simple calculation. It works out that roughly every day another star system is exposed to, for example, I Love Lucy. Okay. So, I don't know how many days have to go by before it actually hits the star system, where there's somebody who, is interested in 1950s humor, but, at least it's not zero.
Wow. Fascinating. Now, one of the other things you said that I want to go back to was you are not in the camp of feeling it's a bad thing to broadcast out, whether it be messages or, an Earth beacon that, hey, we are here. That is a big question in science. Correct me if I'm wrong, right? On whether or not we should be broadcasting out intentionally.
Well, I don't know if it's in science. Maybe it's in the science of sociology or human psychology or something like that. Mm-hmm. It obviously isn't a technical question. Yes, there are people on both sides of that issue. Some people think, let's broadcast. What the heck? It can't hurt, and maybe it'll stimulate a response. And there are other people who will say, oh, no, you don't want to let them know we're here because you don't know what's out there, which is true, of course. We don't know what the aliens are like. If they're friendly, they love poetry, or they're hostile and they love to destroy worlds or something like that. Maybe it's a high school science fair project to destroy another world. Who knows? But you shouldn't take the chance, because you're clearly not the oldest kid on the block. Mm-hmm. The universe has been around a long time. So if your transmission happens to hit an aggressive culture out there, then maybe they'll just, send some rocketry your way and wipe out the Earth, and you'll really be unhappy about that. Yeah, well, okay, I hear that. But the facts are, it's hard to gainsay that argument. It's hard to say that's totally nonsense, because you have no idea. You don't know what the aliens are like. You don't know what they're capable of. But this you can say. If they have the ability to somehow, hurt us, if they have the technology required to do that, which is way beyond our own technology, we can't hurt anybody in another star system. If they have the ability to do that, they probably also have, it's inevitable, that they also have, much bigger antennas than we do, and they'll just pick up the radars coming from our airports. So if you're really paranoid enough to worry about this, then what you should really be arguing for is to stop all radar transmissions, not to mention television, which might be a good thing, but, stop all radar transmissions from Earth, and just accept the fact that the next time you land in Chicago in the winter and it's, foggy and rainy and snow and whatever, who knows what, and you're just going to do that without the radar and accept that forever. Well, I'm not prepared to do that.
Yeah. Well, in the last 15, 20 minutes or so here before I lose you, I want to bring up something that's been in the news quite a bit in the last week. And as my listeners here know, I am fairly skeptical about major mainstream media headlines, and I want you to kind of make sense of this for me. But the big headline that kind of went around, which had SETI's name attached to it, was about a report and statement by a NASA Ames scientist by the name of Silvano Colombano, if I have that pronounced correctly. And some headlines flew around that he made a statement, and this is the silliness of mainstream media that they said NASA was saying this, but I don't believe that is true. That he was saying that tiny aliens may have visited us, and we just don't know about it. Can you explain to me what some of these headlines were saying and what the real story is about Professor Colombano's paper?
Yeah, Silvano Colombano is basically, I think, a roboticist, information technology, IT, a roboticist over at the NASA Ames Research Center, which is about 3 miles from where I'm sitting here. And in fact, I actually know the guy because we interviewed him for our radio show years ago because he was building the snake bots. These are robots that kind of look like snakes. You might say, well, who needs that? But you might need that if, for example, you need to, I don't know, slither through plumbing with your robot to find some sort of problem. I mean, you could have used it, Fukuyama maybe in Japan. But in any case, so that's what he was working on. But there was a conference that was held here at the SETI Institute, just on the other side of the walls here, and he was one of the attendees, and it was a conference about, well, could you decode alien messages from space and that sort of thing. And he said, there are just tens of thousands of reports of UFOs every year, and that's true. And most scientists don't see anything in it. There's nothing in those data where they thought, yeah, this is really, this is a compelling bit of data. I happen to be in that camp. I hear from people every day about this. And I've never heard anything where I thought, man, this could be it. And of course, that would be extremely interesting. Most people accuse me of, dismissing all these things out of hand and not believing them. No, but if somebody just calls up and says, I am in touch with the aliens and I'd like to tell you about it, that's not really good evidence for science. Okay? Mm-hmm. So, but he says, well, maybe the thing is, maybe there is something in it because it doesn't violate physics to go from one star system to another, particularly if you're small. If you're small, then, it takes less energy to rocket you to another star system. And that's where the small thing came out. But we don't really look at these things because in the past, every time we look at them, we come away thinking, no, there's nothing in this. I mean, the government's looked at these things many times. And you can say, oh, well, the government's into conspiracy. But that's an argument from ignorance. There really is good evidence for this stuff, but the government has it all covered up. That's a very, very weak argument. And besides, you have to assume that every government's covering it up too, not just the Americans. But in any case, what he was saying is that, okay, it could be that there are probes in our solar system that have been sent by another culture somewhere. Maybe they're small because they can miniaturize things. They don't send themselves if they're organic, if they're, biological, because that's really tough. But you can send machinery, and maybe they've done that. And maybe the thing to do is to apply artificial intelligence, machine learning, if you will, techniques to all these reports and see if you find any patterns in them that are interesting. Maybe there's something in there. That's all he was saying. I don't think he believes we're being visited either. But of course, as you point out, the media immediately jumped on this story. Oh, NASA is, well, come on. NASA consists of, tens of thousands of people, and the researchers can do their own thing. That's what research is about. The boss isn't telling you, I want you to investigate this and get to this result. That's usually not the case. That's engineering. That's not research.
Yeah, and I knew that the report was very much embellished by the media, which is not, that big of a surprise. But it did sound like, and again, correct me if I'm wrong, that he was recommending that we do analyze those UFO reports, at least, by AI or some kind of algorithm to search through them. Do you at least agree with that, or no? Do you think that that's just not going to be worthwhile?
Well, I would bet that that it's not going to turn up anything interesting. But on the other hand, that's no reason not to do it. I mean, you don't want to throw out the baby with the bathwater, as it were. And in fact, I wrote a little article about this for NBC's website. People can find it if they want, just a couple of days ago. And, sure. I mean, Silvano is not the first person to suggest doing this. Lots of people have suggested in the past, well, look, the problem with the whole UFO phenomenon is that it's not pursued in a very, if you will, rigorous way, right? People don't look at the evidence, and a lot of that has to do with the fact that it's kind of one-off stuff. Somebody will see something, but the next night they don't see it again. So it's very hard to verify anything and collect data. It's really tough. You just get these anecdotal stories, mostly anecdotal stories. I ask people to send me videos and photos if they've made them, and I look at those, and I've never found one where I thought, my God, that's something that couldn't be just, internal reflection in the lens of the camera and that sort of thing. So, what he was suggesting, you say, well, look, it doesn't seem that there's anything good here. There doesn't seem to be any really, anything actual about these reports. But on the other hand, we now have the ability to sift through them very much more quickly than we could have in the past, and to look for patterns that humans might not recognize, but the computer algorithms might. So why not do that? Well, that's like saying, hey, what do you think? Is apple pie and motherhood good things or not? Well, yeah, they are. They're good things. So I think that's kind of where he was going.
I gotcha. Now, the SETI Institute obviously does not take or look into UFO reports, but I've always been impressed in the fact that, and you kind of just brought it up, you do look at evidence that is submitted to you, but, ultimately you don't find value in the sense that it is showing some alien connection to UFOs. Would there ever be a shift in SETI Institute's vision of looking at stuff like that based on, reports like these by Professor Colombano, or is that just something that will never be part of SETI's vision?
Yeah, just to be clear, Silvio Colombano isn't saying that he has any evidence. He's just saying that maybe we should look at the evidence. That's
right.
What he's saying.
And I agree with that. I wasn't trying to imply otherwise.
Yeah. Okay. So, again, I mean, that's something that is said sort of on a routine basis, something like every 5 years. Somebody in the research community would say, well, maybe we ought to look at this. That's been done at least for 60 years now. And of course, then there are efforts, often there are efforts to look at it. And, people say, okay, let's take a look at the 100 best reports, whatever that means. And they always come up blank. They come up and they say, okay, 90% of them we can explain as very prosaic phenomena, it's aircraft or balloons or whatever. And 10% of them we can't explain. But that doesn't prove that they're UFOs. The fact that, the 10% are not explained doesn't really mean much. 10% of the murders in this city are unexplained too, but it doesn't mean that aliens are murdering people. It just means that we haven't solved those particular murders. So there just is never a case where you say, this is it. This is the smoking gun. This one proves that there are visitors. And, it's been done over and over and over again, and always with the same result. So the question is it worth doing again? Well, somebody wants to spend the money to do it. I don't know that the SETI Institute will be doing it anytime soon, if ever, because it's not, to begin with, there's not the expertise, right? The kind of expertise you need for this sort of thing is not the sort of thing that an astronomer would have, for example. It's expertise in, well, can you recognize what actually might be the glint off an aircraft at high altitude from, these measures, whatever they are, or that sort of thing. So, it requires a different sort of expertise. And there are various groups who claim that they are doing this. I'm not sure that they're doing it in a very rigorous way, but, there are people who are interested. And I should point out again, there is a money question here, right? Because if you don't have money, you can't pay people.
Yeah, it does take a lot of money to do research like that. I've always been fascinated by the government side of this. I know you said you didn't find any evidence of any cover-up, and I'm not trying to challenge you in any way, sir. I just have always been fascinated by it, and I would say there probably is definitely a cover-up. You don't now. I didn't mean alien though, so let me make sure that I make that clear. But in regards to this UFO phenomenon over the years, have you looked into that part of it, where the government has, said one thing but done another when it comes to this phenomenon, or is that not of a real big research angle for you?
Well, I don't doubt that the government occasionally covers stuff up. They do that. I mean, I've worked for the government. I had top secret clearance or some sort of secret clearance because I worked in a lab where there were secrets. And you could argue, that's covered up. Well, it was. I mean, it was defense related stuff, right? If what we were doing were generally known, that would give, your potential enemies, and in those days it was the Soviet Union, information that would be useful for them to sort of circumvent the defense of the country, right? Okay, so that, the fact that there are secrets shouldn't surprise anybody. Of course there are secrets. The question is, are they covering up evidence of aliens? Now, you could argue, well, why would they do that? There's just no good reason. But to me, the more convincing thing is, okay, Americans love conspiracy theories. They just love them. I've lived elsewhere in the world, and in other parts of the world, they're not quite so keen on these things. But okay, so Americans like that because they think our government is somehow malevolent and it is going to cover this stuff up. And for its part, the government does occasionally cover stuff up. But you also have to assume that the British are covering it up, and the Bolivians and the Botswanans and the Brazilians and the Belgians. I mean, they're all covering it up. Either that, or the aliens are only visiting the United States, which doesn't make any sense. So that means every government in the world is covering this up. You can't get every government in the world to agree to anything, but you can get them to agree to cover up the most interesting science story of of the millennium somehow. See, so that doesn't make sense to me. And why is it that only the governments get to get all the good evidence? Why is it that my neighbor doesn't get great evidence when a saucer lands in his backyard? Doesn't seem to happen.
Well, one of the last questions I want to ask you, based on when you had said that you don't feel that there's a good reason for them to cover things up. I don't know if this is the reason or not, but I would say one popular theory is that the public generally, with their current mindset, is just not ready. So this would not only apply to UFO admissions that they're connected to aliens, but also if SETI Institute received a signal and we realize that there is an advanced civilization out there, that generally the public cannot handle that. Do you agree with that? Or do you think, hey, if this happened tomorrow, whether it be UFOs or SETI receives a signal, that the public would be fine with it? What's your angle on that?
Yeah, well, we did discuss that a little bit earlier, and because I agree with you, it seems to be that when you ask people, why do you believe in this cover-up? That's kind of a cheap way to argue, because you can say, look, all right, it's true. If I go to the Smithsonian, I'm not going to see an exhibit about UFOs, but that's because the government's covering up all the good evidence. Otherwise, it would be there. That's right. It's like saying, all right, Bob, you know what? I have a cure for cancer I developed in my backyard here, or in the basement. Well, tell me what it is, because that would really be important. And I said, well, no, I can't. I've got to keep it a secret because, it would destroy the medical establishment if we could all cure cancer, something like that. And you would say, well, that doesn't convince me you found the cure for cancer. If you're going to keep the evidence from me secret, then how does that prove to me that you've actually done this? It's the same thing with the UFOs, that, oh, well, there is good evidence. The fact that, the scientists can't find any good evidence, that's only because the good evidence is somehow been exclusive to government agents, and they've all stacked it up somewhere, and you can't get to it. That's really a weak argument. It's terribly weak, and every other government has done the same thing. The idea that the public couldn't handle the news, and we did talk about this a little bit, I think that's nutty. The public could handle the news. I mean, you just have to ask the next 10 people you encounter today, hey, if the CNN came on tonight and Anderson Cooper said, breaking news, scientists find a signal coming from 300 light years away, or we found a probe somewhere near the Earth, would people say, well, that's it. We're rioting in the streets. Nobody's going to go to work. That's the end of society as we know it. I didn't think people would actually do that. I don't. No,
I wish I had another hour with you. In short, my quick response to you, and then I know I have to let you go, is no, I don't think in the short term that would be the reaction where people just start slinging Molotov cocktails and heading to the rooftops to jump off. I don't think that. But I think then the implications as things go on, as time goes on, then people start to think, and then they go, wait a minute, what about those crazy abduction stories that I've dismissed? The human mind will take over and start to fill in the blanks, and then the fear sets in. That would be my initial response. I don't know if you want to add anything to that, but I know my time with you is coming to an end. So I want to say thank you so incredibly much. Your most recent book, Confessions of an Alien Hunter, A Scientist's Search for Extraterrestrial Intelligence. Dr. Shostak, thank you so much for your time and joining me on the Black Vault Radio. I could pretty much talk to you all day, so I really appreciate it.
Not at all, John. And let me just give you 30 seconds in my take on that last comment.
Sure.
Would it change the mindset? Well, look, there are two different scenarios there. One is you pick up a signal. And if we pick up a signal coming from, 200 light years away, we use that number. I don't think people would indeed, get upset, even in the long term. You would just know that there's somebody else out there, right? It's like learning that the Incas exist, in 1500 for the Europeans. Wow. But they still went to work.
Yeah.
There wasn't a sudden revolution in Europe because the Incas existed. The other scenario, of course, is that they come here. And in that case, I agree. All bets are off if they were to come here, right? But if you think they're here now, then you got to say, well, that's not so bad either. They're not doing anything.
Mm-hmm.
Right? They're here, and they stimulate a lot of interesting television shows, but they're not killing people, they're not solving the world's problems, they're not changing the political scene. So if they're here, hey, great, they seem to be pretty innocuous.
Very good. Well, I appreciate that final thought, and thank you again for your time. I wish you all the best, and hopefully you'll come back. We'll talk a little bit more whenever you have time. You are always welcome.
Thank you very much, John. It's been my pleasure.
Thank you. And thank you all for listening to my interview with Dr. Seth Shostak. If you're interested in subscribing, again, go to www.theblackvault.com/show notes. You've been listening to number 18 of the Black Vault Radio. That page will give you links to everything that Dr. Shostak and I just talked about, along with the subscribe buttons to access this show whenever a new episode drops. This is John Greenewald Jr. signing off. We'll see you next time.